In this video, we will explore various functions that can be used with lists. And we will have another look at list indexing. Finally, we will look at the list slicing notation. In Mobius, there are two sets of functions for working with lists. They can be found under primary functions and inline functions. We will look at a few functions from each category. The list primary functions can be used to modify lists in various ways. All the functions have a list as the first input argument. This is the list to be modified. The input list is passed by reference, so there is not need to return the modified list. Let's look at a few commonly used functions. The list.add function adds items to a list. The drop-down allows you to select how the items are added. We will have a look at the first four options, which are the most common. If to start is selected, the item will be added to the start of the list. Similarly, if to end is selected, the item will be added to the end of the list. If the item being added is itself a list, then it will be added as a single item. In the example, the item being added is a list of two numbers. Notice that the result after the add operation is a nested list. If extend start is selected, and the item to add is a list, the items will be added to the start of the list. Similarly, if extend end is selected, the items will be added to the end of the list. Notice how the list in this slide differs from the list in the previous slide. We now have flat lists instead of nested lists. The list inline functions can also be used to modify lists in various ways. Most of the functions have a list as the first input argument. However, this input list is never modified. Each inline function creates a copy of the list data and then modifies the copy. Note that if the lists contain a lot of data, this can be a computationally expensive operation. Let's look at a few commonly used functions. The list join function joins any two values to form a list. And the new list is then returned. In this example, we see what happens when a number is joined to a list, and when a list is joined to a number. This shows another example of the list join function. In this case, the two lists are joined by concatenating them into a single longer list. Here are three more functions. The listLast function returns the last item in a list. The listGet function returns a list of items, given a list of indexes. The listFind function searches for an item in a list. If the item is found, then the index of the item is returned. If the item is not found, then -1 is returned. Now let's look at list indexing. We already covered the basics of positive and negative list indexing. The examples on this slide show how you can get values out of a list. And on this slide, the examples show how you can set values in a list. You may be wondering what happens when an index is outside the list range. In some languages, such as Python, this would give an error. In other languages, such as JavaScript, it would not give an error. Mobius follows the JavaScript approach. When you try to get a value outside the list range, undefined is returned. When you try to set a value outside the list range, the value is set. Now let's look at nested list indexing. Lists can be nested inside one another. In the example, we can see that three coordinates are created, each a list of three numbers. A list of three coordinates are then created. This results in a nested list structure. The example first shows how to get the first coordinate. Then the examples show how to get the first z value of the fifth coordinate. Notice how this uses to consecutive indexes, both in square brackets. Nested list indexing also works with negative indexing. This example is the same as the previous slide. However, it is using negative indexing instead of positive indexing. Positive and negative indexing can also be combined. In this example, we combine indexing methods to get the z value of every coordinate. Now let's look at one more technique, called list slicing. List slicing is a technique that exists in Python. It is also supported in Mobius. It is a useful shorthand way of extracting a sublist from a list. List slicing uses square brackets with two indexes, separated by a colon. The value before the colon indicates the start of the sublist. The value after the colon indicates the end of the sublist. Note that the start is inclusive and the end is exclusive. It may be easier to grasp list slicing using examples. Here are some examples using positive list indexing. Here are some examples using negative list indexing.